Okay, so this is another quick wrap up of series and parallel to make sure you know what you're doing before you do your project. Okay, so if you look down here in the Tuesday slides, these are the questions that you need to answer in your project. All right, you need to make sure that it's clear that you understand these things with some kind of evidence, some kind of drawing, some kind of screenshot, some kind of explanation. All right, so just as a quick review, let's just look at this. Okay, so in series, let's think about what we know. Okay, the voltage drop in the voltage. So remember, a series circuit is one where there's only one path for the charges to flow. Okay. The voltage drops across each resistor equal the total, okay? So you might want to say something like the voltage, we usually say shares, right? Meaning the total equals the sum of all of the rest of them, okay? So in resistor 1, resistor 2, resistor 3, each of them needs to take some of the voltage of the battery, all right? So say, for example, if this were like a 15 volt drop or 15 volts across the battery and the resistors are equal, then each one of these guys would get 5, okay? Later on this week, we'll see what happens when the resistors are not equal, but for now, that's good enough, okay? Right, so you could show some kind of evidence of that in your screenshot. You could give some kind of example, like, you know, my favorite one, the little water cup guys, right? They have to dump some here, some here, some here, and come back empty. Okay, so you need to be able to explain that. Okay, the current is the same in all resistors, right? Because there's only one path for the charges to travel, right? So whatever the current is through one resistor has to be the same everywhere. Okay, and then when you add resistors in series, okay, the current decreases, right? And then you're going to have some kind of evidence of that. You're going to show me that, okay, with your screenshots or whatever. All right, and then resistance, since we know because of Ohm's law, all right, current and resistance are inversely related, okay? So if the current is lower or is less, the resistance has to be more. Okay, so when I add resistors into series, overall it makes the circuit a harder place to travel, right? Because there's more of those roadblocks in the way, more of those accidents in the way, and overall reduces the current in the circuit, okay? So for your project, you can talk about those things. You can show screenshots. You could give examples. You could make like a little comic with the car example or with the grocery checkout example or some other thing that you can think of, okay? But I need to know that all of this stuff you understand, okay? All right, for parallel, right, that's a kind of circuit that's connected where there's multiple branches kind of like this, okay? Let me get a darker color. Okay, so in parallel, the voltage in each branch is the same as the battery. Okay, voltage in each branch is the same of the battery, so they're going to be equal. Each of those things are going to be equal. Okay. All right. Okay, and then the current, right, as those charges come around, they can split multiple ways. Okay, so each charge itself is only going to go down one path, and then they're going to join back together as they come back to the battery. Okay, so the current splits or shares, something like that, and the total current is going to be the sum of all of the currents in the branches. Okay, all right, and when you add more resistors, okay, the current actually increases by the battery, the overall current, right? So you should have seen that in your ammeters in the ones you put near the battery, okay? The current actually increases, which again, because of Ohm's law, right? We know that the current and the resistance are opposite, okay? So, or up, down, okay? So when the current is more, that means the overall resistance is less. All right, so remember, even though we're adding more resistors, they're also adding more paths, okay, which makes it an overall easier place to travel. Okay, so the more resistors you add, the more paths you add, the current will go up overall in the circuit, and it will, and the current will go up and the resistance will go down. Okay. All right. If you want to talk about some of the equations, right, let me go back over here. You could say in series, right, these resistors equal the total. Okay. And in parallel, remember, you don't need to know this. Okay. You do not need to talk about this, but you're actually adding the reciprocals to get the reciprocal of the total in parallel. Okay. That's a little beyond the scope of what we need, but if that makes sense to you to think of it that way, you can do that, right? Because that means every time you add another resistor, you're actually lowering the total resistance, okay? But you do not have to talk about that, all right? But you want to kind of think about it like this, okay? This one I probably could have put here also, the current total I1 equals I2 equals I3. Okay, so in your project, this is what I need you to summarize. Okay, I need this to be summarized into your project. Okay.